All right, welcome to the talk on Scala tricks. My name is Venkat Subramaniam. We're going to talk about Scala, the language, in terms of a few things we can do with it. I won't go through an introduction to the language per se, but we'll look at a few things we can do in the language. Best time to ask a question or make a comment is when you have it. So please don't wait till the end. If you have a question or a comment, raise your hand. If I'm not responding to you, usually means you're not in my line of sight. Just wave at me or start speaking and draw my attention. I'll be more than happy to listen to you. So let's get started. We're going to talk a little bit about Scala, and then we'll talk about a number of things we can do with it. But first question, of course, is what's Scala and why should we really care to use a language like this? The really interesting thing about Scala is a hybrid functional programming language. What it means by hybrid functional is that it is a functional programming language, but it also allows us to do imperative style of coding like we do in Java, so it gives us a flavor of choosing between multiple different paradigms to implement things. So this gives us a certain advantage, but may also have a certain disadvantages, because we have to kind of force ourselves to pick the paradigm rather than the language forcing us to do one thing in a certain way. It is a language which is very concise. It is concise in that you would write a lot less code in Scala. And writing less code is a good thing, because then more of our code is more productive and work towards the application. You're looking at about 40 to 60% reduction in code size compared to Java itself. It is a statically typed language. I think we should never say Scala is statically typed like Java is, because that's an insult. Scala is actually statically typed that we don't have to actually do as much typing with our fingers, because the language is more statically typed. So there are some of these really nice advantages. One of the things we will notice when it comes to Scala is that it's very highly expressive, very easy to work with higher level of abstraction. Of course, there is some disadvantage, and that is that there's a learning curve. We have to learn the language and take the time to really get better at it before we can make use of it. But that's true of a lot of different languages. Scala is no exception to that. What we're going to learn here in this session is I'm going to look at Scala to see a few things we can do with it in the next about 45 minutes or so, and look at what things we can do in this language compared to what probably would be doing already in Java, and see how we could do it. Now, one of the real benefits, I think, of these languages is this is not an all or nothing proposition. You could be developing application in Java, but then you realize you could do something fairly easily and quickly and more expressively in Scala, and you can quickly intermix that. So you could have Java code and Scala code on the project, depending on which component you're implementing, and you can go back and forth with it. So those are some of the nice things you could do. Let's talk about reading a file for a minute. How would you go about reading a file? Suppose I want to open a file and display its content. I'm sorry to do this to you right after lunch, but think about this for a minute. How would you do that in Java? I know you're thinking through, okay, I'll open up a file reader, and then I'll open a buffered reader, I'll start reading through it, I'll put a while loop, and then you realize, wait a second, but I have to put those try-catch blocks. And by the time you're done, there's about 30, 40 lines of code to read a file. Remember that? And you should never do this before lunch, because others go eat your lunch in the meantime, right, while you're trying to do this. Well, how would this look like in Scala for a minute? Let's go ahead and say scala.io, and underscore is kind of like asterisk. You're just importing everything from that particular package. And I want to read something. What do I read? And I want to print out what I'm reading. But what am I going to read? So I'm going to say source.fromFile. And what file am I interested in reading? Well, why not just read this file itself? It's called sample.scala. That's the name of the file. I just want to read this file itself. And then when we finish reading the file, I just want to make string and print the content of this file. That's all I'm doing right here, right? I want to just print the content out. How would this look like? So that's the entire code I have in here, and right there is the code to read the content and display it right there. There is no ceremony. My good friend Stuart Halloway termed this. He called it essence versus ceremony. And essence is where you focus on what you really want to do. What is ceremony? Anybody here loves ceremonies? Not really, right? Because ceremony keeps you away from doing the fun stuff you want to do. And ceremony is boring, and it kind of really, demotivates you. And the beauty in Scala is you can only have fun. You don't have to go through ceremony, right? So it really gets you directly to what you want to do, rather than putting all those try-catch around this and so on. Now, talking about try-catch, one of the things that Java did was to implement the checked exceptions. Checked exceptions are evil, isn't it? Because what happens? The language tries to tell you what's the right thing. And you should know, you should never tell the programmers what's the right thing to do. Because programmers are fairly smart, right? And you tell the programmer, you will catch exception. What does the programmer do? He says, let me show you who's in power, and puts empty catch block. There is no way to win this battle, right? So Scala says, you know what? Let's give the responsibility to the programmers. Let's treat them with respect. Let them do what makes sense. So yes, there are exceptions in this code, and sure, things will burn and crash, but we would write code defensively and put exceptions around it and handle it rather than being forced by the IDE to put catch blocks around. So that's one of the beauties that you see here, is what's very simple to do this. Let's talk about creating lightweight, immutable objects. I'm going to show you a couple of different ways to create objects. But how do you create objects in Java, first of all? Okay, but I want to create an object of my own class, which means I have to first create a class, isn't it? Let's think about Java for a minute. So let's say I want to create a class called car. How would you write it? Oh, forgot, you have to put public first of all, right? Now, and then what do? You say private int year. Oh, I forgot to put final, of course. And then you say private over here, int miles, to create the miles. Remember that? Are we done? No. We have to say public int. And then we have to put get year, because we need to access the year. Return year. And then, of course, we want to say public int get miles. We want to return the miles value, remember? So you say return miles. And then, of course, you have to say public void set miles, because we want to set the miles. And then comes the beauty. You have to say this dot miles, miles equals miles, because there's no other variable in the world. We have to overload that variable name and make bugs in the code, right? And we can write code like this. Are we done? No, we have to write the constructor still. But it's probably a good time to take a break before we continue, right? Now, you're probably thinking, this is not fair, Venkat. We never do this in Java. We only write these variables, and then we gently right-click on our IDE, and before our eyes, the IDE vomits the rest of the code, right? So what you're telling me is not only do we need a language that is verbose, but it has to ship with an IDE that continuously vomits. And who's going to maintain that vomit if that happens, right? So it really becomes a burden for us to do. How would this look like in Scala for a minute? Well, of course, in Scala you say, I want this class to be public. Well, how many times do you really create classes that are not public? Not so often. So why bother saying public all the time? It is public if you don't say anything. And then you say, I want to define this as a year, which is an integer, but I want this to be a final variable. You say val over here. And then you say var, and then you want this to be a miles value, and then you say integer, and then you can get rid of the rest of the stuff. You say, wait a second. What did you just do? Well, I created a class for car, and I can initialize this. Yeah, but you did not write the constructor for it. No, it's done. You don't have to write the constructor. It's already written for you. So if you run this code, it gives you an error because you're not giving the value for the constructors over here. But of course, we could give the constructor value 0 and 2013 as the miles value. We could do that fairly easily. So as you can see here, we're able to create this object very easily. And what about writing all those methods we wrote? No, you don't have to write a get year because getters are available already. Can I set the year? No, you cannot because it's a val. Can I get and set the miles? Yes, you can. What about the constructor? It's written. So I know you're feeling nervous, right? If all that is written, what do I do? Go home, right? Why do you have to sit there and write stupid code that can be written for you behind the covers, right? That is one of the beauties. But it only gets better. What I want to do is I want to create an object, But I really don't want to spend my time even creating classes. There are times when I want to create a lightweight object and throw it across the fence and say, here, go take it. When would this happen? Like in message passing, for example, if you're using Akka, for example, you want to create a lightweight message and toss it across the fence and say, here's my object, go take it, do something with it. So how do you create an object? Well, there is one kind of animal in Scala which I really like. It's called a tuple. And tuples are beautiful in my opinion, because tuples are easy to create, they're very lightweight, and above all, tuples are immutable. Once you create an object of a tuple, you cannot modify it. So this really fits nicely well for doing concurrent programming, if you will. So let's look at an example. So I'm going to say over here, we'll create a variable here. So what is the variable I want to create? Let's say create person is the method I want to create. Let's say create person. And this create person is going to create a person for us and return a person. Now, what kind of person do I want to create? Let's create a tuple. That's how simple it is to create a tuple. Simply put a parentheses and put your stuff in it, and that becomes a very simple tuple to create. So now if you basically say here is James over here, and then of course I say Bond over here, that's a person we created. So we could set this. We could say 007, for example, equals create person. And once we create this person, we could print this object. And so what do I want to do at this point? I'm going to simply say 007_1 and 007_2. Now, this is going to print the first name and the last name of this particular person, obtained from this tuple, obviously. Now, looking at this code, what did we just do? Well, a tuple is a very lightweight object. It's immutable. You can easily create instances and use it. Now, if you're dealing with, the syntax may look a little odd right now. And if you're dealing with an array, you could go out of bounds in an array. And what do you get? You get a runtime exception. If you're dealing with the array list, you may go out of bounds with an array list. What do you get? You get a runtime exception. Well, not so with the case of a tuple. Tuples actually have a preset number of elements at compile time. So if you go over bounds, you get a compile time error, not a runtime error. So you would get an error at the compile time saying, I don't understand what _3 is or _4 is. And of course, these are very well indexed. Of course, you're looking at this and saying, but I don't like that _1. Can this be a better name? There's a very easy way to fix it. Get over it, right? So there is no reason to be spending time on it. That's the way it is in Scala. And you just basically use this index notation to get access to these variables. Sure, that's a tuple. You cannot modify it once you create it. But if you want to make this a little bit more readable, you could actually do that. And you can create an anonymous instance in the case of Scala fairly very easily. And you can go away from using tuples. Let's take a look at an example of how we could do this. So I'm going to go ahead and change this to a first name. And I'm going to change this to a last name over here. And of course, those two don't exist for a tuple because we haven't created any of those parameters. But we're going to change it from a tuple. So what we're going to do instead is we're going to simply create an object with a new, it kind of gives you a feel of a JSON object, right? It's kind of like that. Very lightweight, except it's immutable as well. And then I can say val first name first equals, and then I could say James over here, and then we could say var last equals, and then we could say Bond over here. And now we are creating an instance basically of a value in this particular case, which is going to be a new instance that I want to create right on the fly, and I want to return it in this particular case. I'm getting an error. Let's see what this error says. Where's the error coming from? Maybe you can help me debug that. So it's complaining. And this could be a Java. Actually, there is a warning more than an error, but of course, we can take a look at that later if you're interested. But that's pretty much the deal here is that you are able to get to an anonymous type and use it fairly simply. And this becomes, again, a lightweight object that you can create. And you're able to use more civilized parameters to get to it as well. As you can see, that works really nicely. Now, Scala is a fairly powerful language, but to a certain extent, I would argue, there are certain limitations in Scala as well. And one of the things I like to play with languages is to create DSLs, or domain-specific languages. And personally, I would argue Scala probably has some limitations to DSLs, even though other people disagree with me on that. And the reason I say there's some limitations is that, to me, for a language to be used as a language to create internal DSLs, it needs to have two capabilities. One is it should have a very lightweight syntax and a fluent syntax with a little or no ceremony. And I think Scala passes that, right? In Scala, we don't use semicolons. Anybody here thinks that semicolons are very important and we need to use them? Not really. Nobody is raising their hand, right? We have taken the years of abuse with semicolons. In Java, we keep putting semicolons over and over and over. I have a proof that semicolons are bad. Just take a look at your hand for just a minute, if you will. There's a reason why your pinky is the shortest finger. And the reason is it's taken years of emotional abuse. Because every time you code, all these fingers do useful coding. And then you take this and hit the semicolon, it says, why me, right? Because it doesn't have, anything else to type. But when you program in Scala, it actually becomes a little pinkish in color. It shines a little bit. Emotionally, it's like, you can cherish it. Anyway, coming back to this, in the case of Scala, you don't put semicolons. That's a great thing. Even parentheses are optional. So you could do something like, for example, if you have a car object like we did a few minutes ago, you could say car.turn, for example, and you could say left over here, or you could simply say car turn left like this, and both of these syntax are actually valid. So in Scala, you can drop semicolons, you can drop parentheses, you can drop periods, and all these can be left out. So this is really a good thing for creating fluent syntax to create DSLs. But on the other hand, if I really want to go very dynamic in creating DSLs, I really want to have meta-programming capabilities. And of course, Scala quite doesn't have that kind of meta-programming capability like language like Groovy or JRuby has, or even Clojure for that matter. But ignoring that for a minute, you can push this a little bit further with a few interesting concepts. For example, what if I want to say 2.days.ago, and I want to write a code like this, right? So I'm going to show you how we could use implicit conversions to achieve this. So if I run this code, obviously I get a compilation error because the code says, I don't know what you're talking about. So because days is not a method on 2, so it gave us an error right now. We're going to make this code work. In the next about 5 minutes, we're going to make this code work. But we got to prepare a few things before we can get to that point where the code will work. So let's take a look at how we can do this. We'll kind of refactor this code and get to that point. So the first thing I'm going to do, remember this is the code I want to work, so I'll comment it out for now. But let's start with something a little different. I'm going to say new int util, and then I'm going to pass the 2 to it. So it's a little bit verbose code, not really close to what I want to achieve, but we will get there eventually. Let's see how we're going to do this. So I've got an object of int util that I'm going to create. Well, what's this int util? So I'm going to say int util is a class that I've created. It's going to have a number as a parameter to begin with. This is going to be an integer. In fact, I could even say a val for it. And this could be just a value that I pass to it as number. Let's do that. So we start with the number, which is a value object. And let's say this is an integer value. So we'll start with that. So you can see that in this particular case, I can start out with it, and it just gives us the object of this int util. Now I'm going to call days on it. Well, in this particular case, the days doesn't have a whole lot of meaning. It's kind of a noise method. It gives a nice English connection. But to be fair, you could also say, instead of days, you could say minutes, in which case you may create a different object and return. But in this example, we don't have to go that far. But what is days in this case? Well, I'm going to create a method called days, and this is simply going to return the current object itself, as you can see. So that was enough to do the work. Now I'm going to go ahead and create a method called ago, and the ago method, by the way, in Scala, you could either put the parentheses or leave it out. If you do put a parentheses, you could call it with parentheses or without it. But if you don't put the parentheses, then of course when you call it, you wouldn't put the parentheses to make the call. So what am I going to do in this particular function? Well, here's the ago function that I want to implement. And within the ago function, I'm going to simply say, get the current date, for example. So let's say var will say today equals calendar, and then dot get instance. So I'm getting an instance of a calendar. So let's go ahead and import java.util.calendar for a minute. And now that I have a calendar, I want to simply return the calendar here in this particular call. So we can see that it's returning the calendar object. We could even say today dot, well, we were told 2 days ago. So we could say add and say calendar dot day of month, for example. And then we could say this is going to be a minus number because I want to offset this particular date. And then we could say dot get time to get the actual time from this. And you could use other calendar implementations if you're interested in. And that's a February 4, as you can see. That was not too bad at all. But you say, wait a second, that's great, but we really wanted to get down to using this syntax, but how do we get close to doing that? Let's get to that point in just a second. So I'm going to create a function here, and the function is going to be from int create a wonderful int util. I call this because to emphasize it doesn't matter what you call it, right? And what does this function do? It takes an integer, let's call it as a number, and this is going to be an integer I'm sending to him. And what's he going to do? Simply returns new int util, and then he's going to give the number for that. So I just basically created this weird function called from int create wonderful util function. So what is the benefit? The benefit is rather than calling that creating this object, I could have just simply said that. It only got worse at this point, but the code is still working. But the beauty of this is now we can get rid of this part here. And of course, Scala is giving us an error, but we can simply say implicit over here. And then Scala will say, I can go through and get that value for you and use it directly. So what did we just do? We used an implicit converter. Now, of course, implicit conversion has two purposes. One, to make code small, and the other is to scare the heck out of people reading the code, right? So it's a pretty good feature in that regard, right? Because you look at this and say, where in the world did this come from? So that's an element of surprise there. So don't go overboard with implicits. It can really be agonizing for people who don't know what you're doing. But be a bit careful in using implicit. So, and in this case, you can see how implicit being picked up. And so what Scala does is, when you make a particular call, it says, I really cannot use this particular function here, but hang on a second, let me go out and find if there are implicit converters, and if I can apply any of those converters. Now, of course, if it finds an implicit converter, either directly in the file or in one of the imports that you have in your code, it would go get those and then use it. And of course, if there are ambiguity in bringing imports, the Scala compiler will give you an error saying, I'm sorry, I cannot bring this in because there's collision. And of course, you can then deal with it in your code. So that's something you could definitely handle. So we looked at a bunch of features. I'm going to talk about two more features here that are going to be pretty interesting. One is compiler magic, which is the tail call optimization. This is one of my favorite features. I really like this feature, and the Scala compiler does a very useful and interesting job with it. Let's take an example here of simply finding the factorial of a number. And I'm going to say, given a number, I want to find the factorial. Now, there are a couple of different ways to write this code. We could write this as a pure iteration, where we could just loop through and do the code. So, for example, we could say var fact equals 1. We could be returning the factorial of this number. So we could say, for example, factorial of 5. And of course, in this case, it's a 1, but we got to change it really quickly. So we could say where I is going to be a value from 1 to n. And then we could simply say factorial times of I and ask him to do the work. Now, this is, of course, iteration, and we all know that iteration is so boring, right? We've done this for a long time. What fun is that? The real fun is in writing recursion, isn't it? Because if you write recursion, your friends will want to hang out with you in the night, right? They are like, this is cool. He can solve a problem with solutions to a problem. How awesome is that, right? So absolutely, you want to do that. So how do you write this as a recursion? So you invite your friends and say, look, I can show you recursion. And then you say, if n is equal to 1, then return simply the value of 1. Otherwise, return n times factorial of n minus 1. And you show off to all your friends how cool this is and how interesting the recursion actually works. Well, this is all great until you have this one person in the party who doesn't like you and says, hey, here's an idea. Why don't you go put this into a large value, and then it blows up on your face. And the party is over, everybody goes away, and they don't want to return your phone calls anymore, right? And that is not fun. That's not the way you want to be. So how do you fix it? Recursions are so awesome if only we can really make them work to our advantage. Well, there's a fantastic book out there called SICP, which stands for Structure and Interpretation of Computer Programs. It's a highly recommended book. I definitely recommend reading that book. In SICP, what they talk about is a distinction between a process and a procedure. A procedure is the code we write. The process is the code that runs. And of course, we write code in Java, we write code in Scala, whatever language it is. The compiler compiles the code, and usually a JIT optimization optimizes the code further. So already we know what we write is not what we runs. The procedure is different from the process that runs. But what these guys are talking about in this book is they talk about having an iterative procedure and then running it as an iterative process, which is what we did a few minutes ago. Wrote it as an iteration, ran it as an iteration. An alternate way is to write it as a recursion and run it as a recursion. And we did that just now until it blew up. But what would be really cool is to write it as a recursive procedure, but very quietly under the covers, it runs as an iterative process. Meaning the compiler is smart enough to look at this and say, aha, I can optimize this into a pure iteration under the covers. So then what happens? You get to hang out with your friends without blowing up the stack, right? And when somebody says increase the value, you can tell them this, right? Of course I can handle that. So how cool that is when you can do that. Well, the compiler can do this for you already, but you got to do a little bit of work for that. Let's get back to this code for a second. And here is a simple recursion, but we're going to say, what is the last operation you're performing in this particular call? Well, of course, the last operation is the multiply operation, but we don't want to do that. We want the last operation to be the call to the method itself. So what I'm going to do to make that happen is, I'm going to add a new parameter here. A fact is going to be an integer over here, and I'm going to say if the number n is a 1, return the fact. Otherwise, go ahead and do the partial math right away. So call the fact times n, comma n minus 1. So now we can go back and call this method very easily, and it still produces the same result. But what's the difference? The difference, though, is we are doing tail call optimization. The last call to the method is the method itself, not some operation you have to perform when you return. And the compiler very quietly optimized this into a simple loop under the covers. So if you now go back and put this to a very large number, you can see it doesn't blow up the stack anymore. Of course, it failed in the overloading of the, or exceeding the capacity of an integer, but that's pretty easy to fix. We can simply say, this is going to be a big int value that I want to use. Change this to a big int as well over here. And of course, the return is going to be a big int as well. And then we can say, if n is equal to a big int of 1, then return the factorial. Otherwise, do the remainder of the operations. And of course, the code is running, no more Stack Overflow exception. And then we get this very large number, which is the factorial of 50,000. Don't ask me why I need that information. So that is an example of how we could really avoid from blowing up the stack. Now there is one small problem here though. In the name of refactoring, I could come and make some change, and even though the result technically is going to be correct, it is no longer tail call optimized. Now you could argue if you only had a unit test to find this out, sure, I'm a huge fan of unit testing. But at the same time though, if a compiler can catch problems for us, why not? So you can say scala.annotate tailrec, for example, and you can see that the code is still working with no errors because this code is really tail call recursive. On the other hand, if I were to refactor this code and in the process it's no longer tail call optimized, we get a compilation error because of that annotation now, and Scala says, what are you smoking? This is no longer tail call optimized, right? So you get a very direct compile time error rather than relying on the runtime to really tell you that. So that is an advantage of tail call optimization already baked into the language with the compiler. As you can see, it's fairly very effective. What I want to show you next is two features combined together. This is one of my favorite features, which is called traits. And then we're going to see how to use the traits to do something else. So let's look at an example of using traits. So let's say you're programming an application and you have a human class. And then within the human class, maybe there is a name for a human. So I'm going to say name is going to be, let's say, a string. And I have a method here called listen. And the listen method simply says, I am, so it's going to say the name. So let's say plus name, and then plus listening, right? So listening. So here I have this method. I want to call this, so let's say var Sam equals new human Sam, and I want to call the method sam.listen, and we can see that this code is going to be listening to this, and it says I am Sam listening. But what did we do? We are modeling something here. We wrote a human, and we wrote a listen method. But what is listen really? Who listens, by the way? I know, you're laughing. That's sad, isn't it? Who listens? There was one guy in one of my previous talks. He was kind of right in the front over here, and immediately he was quick to answer. He said, wife. And everybody kind of stared at him for a minute. Really? He said he's been married for about 2 weeks. We said, yeah, that's fine. You will realize this over the years, right? And, you know, do wives listen? As much as do husbands listen? My wife tells me this, that I have a very selective hearing. I have the most wonderful wife. She's very kind to me. And one day she found out that I keep listening to her. But she then asked me a question. There was no response. That's when she realized that I was not listening to her. And she's extremely smart. So one day she was talking to me, and obviously I was coding away, not listening. And suddenly I get an email. So I switch over to read the email, and she sends me an email from the kitchen and says, now you will respond to me, right? So very clever. So we have selective hearing. We don't listen to spouse normally. That happens. But let's go back to listening. Who do you think really listens? Friends listen, isn't it? Isn't that what friends are for, honestly, right? Your friends listen to you, right? Otherwise, you got to change your friends. Your friends listen to you. You go, at the end of the very tiring day, you sit down, and your friend comes over to you and says, how's life? You say, you know what? This job sucks. And what does your friend say? He says, tell me about it. You say, maybe this job is not the one that sucks. This boss sucks. And a good friend, what does a good friend say? Says, tell me about it. A bad friend says, maybe you suck, not your boss. Right? That's how you know who the friends are. But anyway, friends really are the ones who listen to you, right? So, but we kind of stuck this in the human. But where is the friend? By the way, there is one friend who is the dearest of the friends you can ever find on planet Earth. And this friend always listens to you and never speaks back to you. What am I talking about? A dog, thank you. What a wonderful friend, right? Now, I want to model a dog as a friend who listens. How do I do that? Bright idea. Inherit dog from human. No, dogs don't like it. So, any other ideas? What would you do in Java, by the way? Oh my goodness, interface. A friendable interface. So you have a friendable interface. Now you have a human, you have a dog. Wait a minute, but these two methods are over here. They're not in the same interface. Interfaces cannot have method, at least not until Java 8. So what can we do with implementation of this method? You create an abstract base class, friendable abstract class. Stick this method in there, and you inherit this class. Oh, wait a minute, you cannot inherit from multiple classes. Back to square one. Hey, here's an idea. Inherit the human from friendable interface and delegate to this friendable abstract class. Make sense? Yeah. But if that is the way you're going to do it, why shouldn't the language do it for you? Ta-da! That's exactly what Scala does. So Scala will do this for you rather than you having to endure the pain. So a trait is an interface. But if you put an implementation to a trait is an interface plus an abstract base class. They got a buy one, get one free going today, right? So you get an interface and an abstract base class available to you the minute you write a trait. So notice what I'm going to do now. I'm going to simply create a trait here called friend. And within the friend, I say name is a string, which I haven't implemented. And I put the listen method in here for you. So far, so good? Now what am I going to do? I simply go to the human and say, hey, human, you extend from a friend. So extends friend. Notice the code basically still works because we extended it. But let's go a step further with this. So I'm going to now say class, and I'm going to create an animal which extends, well, animal has a name as well, name. And what am I going to do now? I'm going to create a class called dog. What does a dog do? Override val name over here, which is a string. And I'm going to then say, basically, in this case, dog inherits from an animal. So we'll say extends from animal. So now that I have done this, let's try this one more time. Let's say a val, actually, why a var? So val, we'll say buddy equals new dog. And this dog name is Buddy. and I'm going to go to buddy and say buddy.listen, right? Well, of course that doesn't work because dog doesn't have anything to do with friendship at this point, but we'll say with friend. So we made a dog a friend of animal as well in this particular case. So what are we doing in this particular case, in this particular example? So all that we did in this example is, let's record from this, override. What did I do wrong? Anybody sees the error here? The dog extends from animal. Oh, of course. I need to tell him that the name is to be passed up the chain. There we go. So you can see how that's working, right? So what did we do? I could have a function called, talk to. Whom do you talk to? Somebody who listens to you, right? A friend. And this is going to be a friend I want to talk to. And I say friend.listen. And now I can say talk to Sam. You can say, Sam, would you listen to me? And Sam is listening to you. But you can also say talk to Buddy. You know, it's been a very long day when you have a long talk with Buddy. And you can see that that's working as well. So far, so good? So we're able to reuse some code. Let's push this a little further and see how this goes. Get rid of all of that for a few minutes. Let's come back here and do this one more time. Let's go ahead and say I have a class called, what? A cat. So I create a cat. And cat extends from animal. And I'm going to say val alf equals scary cat, new cat, and alf. And I'm going to say alf.listen. Will that work? No. That's because cats are not friends. Right? In fact, you go home at the end of the tiring day, this cat kind of looks at you and says, why are you here? Why don't you leave some food and go back? Right? So cats are not friends. Anybody with a cat here? You have a cat? Is your cat friendly to you? No. See, I told you that, right? She's honest. Anybody else with a cat here? Do you feel that sometimes your cat is friendly to you? Yeah. That's called illusion, you know that. But let's try. Could you share your cat's name with us, please?
Clinton.
I'm going to ask your help. What's your name, though?
Micke.
Micke. Okay, well, let's see if I'm not promising anything to you, but we'll try. Let's try. No promises. The conference doesn't promise anything, right? Okay, all right, just to be sure. I don't want him to complain that my cat is, not friendly anymore. All right, Val, help me with spelling your cat's name.
Clinton, that's Bill Clinton.
Spell. How do you spell it?
C-L-I-N-T-O-N.
That's a very bad dog. A cat, rather, right? A cat with the name Clinton. Okay, we'll talk later, okay? So, new cat, Clinton. Let's see, Clinton.listen. Sorry, we tried. It doesn't work. But before we give up, one more time, with friend. There you go. What did we just do? Cats are evil. Sorry, I can't help you. But Clinton is special, right? So what we just did is we injected a trait into one particular instance. That's what we did. All cats are evil, but Clinton is special, right? So in other words, not only can we have injection of traits into classes, we can also have injection of traits into special instances. And this gives us the power of mixing. And what is this actually? Traits are nothing but compile time mixins provided into Scala already, so we don't have to endure the pain. So where do we go with this? This gives us some really good design possibilities. How many of you have used multiple inheritance in the past? A few of us raise the hand. Others know never to raise the hand in public for that question. Very good. And you're done most likely in C++, right? How did that go? Not so good. Because multiple inheritance is like a gorilla. It is cute when you see it in the zoo, but don't bring it home, right? It really causes havoc. Well, that's exactly what happens. But what if the interfaces get together and say, I will not fight with each other, but we will cooperate? Well, that's exactly what traits do. They cooperate with each other. Let's look at an example of how we can do this. I got a class called a writer class, an abstract class called writer. And this abstract class called writer is just, you can have different types of writers. There's a write method, which takes a message as a string over here. And what am I going to do in this method? Well, not a whole lot right now. It's an abstract method. Great. Now I want to have a class called string writer, which is going to extend from writer. And I'm going to simply define the method, override the write method over here, which is going to take a message. And what does it do? It writes it to a target.append, and it's going to append that message to it. What's this target thing I'm talking about? Well, a target basically is going to be a new string builder, and I'm going to put this into a string builder. There we go. Now I also want to write an override, define a toString method, which simply says target over here, dot toString. So we got set up a few things nicely. Now what I would like to do with this example is, we got different types of writers. I can have string writer, file writer, socket writer, encrypted writer, who knows, 20 different writers. Keep that in mind, right? A lot of different writers. But I want to write something to this. So write stuff. This takes a message, actually a writer, and here is my writer I'm going to take. And what am I going to write? I'm going to write something very important. Writer dot write. And I'm going to write, this is stupid. So we wrote that. I want to print out what we wrote, so writer. So let's see if this works. So write stuff, and let's send to him new string writer, and asking him to write to the string, and it wrote, this is stupid. So that seems to be working fine. Now, a little time goes away, and then we are told we not only want to write stuff to the writer, sometimes we want to write stuff in uppercase letters. How do we do that? Well, first I thought is I could change this code. But that's not a good idea, right? Because then you lose the ability to write stuff without uppercase. Well, you could add another function to this. How do you do that? Well, you could add a function, but where do you add it? Well, I don't want to add it to the string writer. That's not the right place. What about to the writer? That's not the right place either. We pollute this interface with a lot of methods. What do we do? Well, traits come to the rescue. So notice what I'm going to do. I'm saying trait, and we'll call it as uppercase filter. And this guy says extends from writer. And this extends, by the way, doesn't mean extends. It simply means you can mix this trait into classes that implement writer. Then you say define write, and message is the string. And what are you going to do here? You're going to say message dot to uppercase. So you transform to uppercase. But where do you put this? I want to put this into the write method. But what is that method? Into the super. Now the super here doesn't mean super either. The super here means the object to my left. In other words, the object form a chain. So one object points to the next object that points to the next object, and they all form a chain, and a super really goes to the next object. Now they could have called it something else other than super, but then you would understand the code, so they cannot do that. So basically in this case, they just reuse the word called super. Are you with me so far? Okay, if that is not enough, you would say override here because you are really overriding the method. But you also want the left object to have this method too, and to enforce it, use this deadly combination called abstract override. The best thing to do with this is not to talk about this again. Okay, so now that we have those two, what do? Write stuff, new string writer with uppercase filter, and notice in this case how nicely we were able to chain this together. You kind of see where I'm going with this, right? So I'm going to throw one more example into this, but this is a sad example. I travel a lot for work, and I go around the world, I meet a lot of interesting people, I have a good time. But I found out over time that I have turned into a bad guy. And that's really sad news when I came to know about this. Because I was home one day, I said something, and immediately my little boy ran to my wife and said, "Mommy, Daddy is a bad boy." And he whispers something. And my wife comes to me, now it's a time to discipline the husband, right? She comes over to me and says, "Did you say the bad word to my son?" And I said, "What bad word? Did you say the S word?" And I kind of said, "You mean," and I said the S word. She said, "Not that S word. Did you say stupid to him?" I said, "Yes, I did say stupid. What's wrong? You're saying it again." And I said, "What's wrong with saying stupid?" She said, "I'm raising these children with good manners. They cannot go around and call people stupid. Don't do that." And I came to know that you shouldn't call people stupid. Well, you know how sad that is, right? So I learned that. I said, "Yes, ma'am, I will not say stupid anymore." So then on, when I'm talking to my children, I got to be very careful what I say, right? No more use of the word stupid. So I want to fix this problem forever. So I create a profanity filter. And the profanity filter says, I'm going to write this, but what is it going to do? Here is my method called override write. And within this method, I will simply replace any word that I use called with the word stupid with the word There you go. So let's see if this works. So I go ahead and call write stuff new string writer with profanity filter. Life is good, isn't it? Now you see where I'm going with this. Now I can do this. I can say write stuff new string writer with uppercase filter with profanity filter. How about that? We are mixing them together and they all cooperate nicely, isn't it? Your request went to the profanity filter first. What did it do? It removed the word stupid. It says this is beep. And that goes to the uppercase filter, which converts to uppercase and then nicely printed out. Make sense so far? So notice the beautiful chaining that's going on, where you send the request to this first object, it changes to the second object, which changes to the third object, and then eventually the target destination object. So far so good? But you also notice one other weirdity. If you observed what I did, I replaced the lowercase stupid. So as a result, if I now try write stuff new string writer with profanity filter, with uppercase filter, what's going to happen? It first converts to uppercase, and my profanity filter doesn't say it. But don't worry, this is all good. Because when I am angry, and I say, this is stupid, my son's eyes widen, and my wife says, Daddy is upset right now, be quiet. So this works really well to my domain, right? So the point really is that we can really use the object chaining very nicely to put together. And by the way, what did we just notice? We just elegantly implemented this wonderful pattern called the decorator pattern. And the decorator pattern just seamlessly works in Scala. In the case of Java, you would have a corporate meeting to use the pattern. Whereas here it just flows nicely and works. And that is very well done. As you can see, it really flows through. And rather than colliding with each other, these kind of combine with each other and work together. So it's a very, very interesting pattern, and you can see how powerful and how concise this language is, and there are so many things we can do if we kind of adapt to the power of this language, and you can intermix this in Java. I hope you enjoyed it. That's all I have. Thank you. I would be happy to answer any questions if you have. Any questions, comments, just about anything. Or your thoughts, just about anything.
In the 2 days ago sample, can you remove the points?
Oh, that's a great question. Can you remove the points in the 2 days ago? That's going to be a little bit more difficult to do, but you can try. That's going to be a little bit. That's why I was kind of giving you a little of a caveat. To do a full DSL, I find that I need a little bit more power than what's available. In some specialized cases, you may be able to do that, but going forward from there, you probably would hit the limits. Good question. Anything else? Please.
Is there anything good way to declare not input parameter, but to declare output formatted? So if it returns something, then I want to give some decorators that just convert this output later.
Oh, so it's kind of like a parsing thing?
Maybe, but
The-
to have it in language level, I could do it in some high level, but if there are such nice feature for decorating input parameters, there could be.
I don't know. I don't know if there's any facility for that. Don't know, please. Yep.
So when Mark Langell spoke yesterday,
Yep.
the question at the end about the tail call optimization in JVM,
Yep.
and he said that JVM does not have tail call optimization at the moment.
Correct.
Scala has.
So let me address that a little bit. Scala does tail call optimization at the compiler level. I programmed with Scala, so I know what it is doing. Then I looked at Groovy. Groovy does tail call optimization at the library level without the compiler optimization. And what they do is they basically have a closure, and you call trampoline method on the closure, and then when you call it, they say, give me back a result. Because remember, Groovy is dynamically typed. And as a result, it says, when I get it back, it says, if this is a closure, call again. If it is not a closure but a data, return it. So very smart. So I kind of looked at these two, and I've been playing with Java 8 Lambda expressions, and I wanted to implement tail call optimization. I know the language doesn't do it. I spent 8 hours on this one Sunday. And at the end of 8 hours, I had about 20 lines of code. It sucked really bad. I didn't like it. But I left it there. I said, yeah, I got tail call optimization working. 2 days went by, I got excited again, I spent another 2 hours and refactored the code. It came to about 4 lines of code. And so there's tail call optimization. And about 2 days later, I was on the treadmill, and it suddenly dawned on me that there's another thing I could do. If instead of thinking about this as a tail call optimization, if I think about this as a lazy evaluation of an infinite collection, think about that for a minute, right? Well, Java 8 supports infinite collections. So here's what I did. I was able to really do this without much effort at all. Let me quickly see if I can connect to this. I got another minute on my hand. Let's look at this real quick as an example. I'll zoom into this in a second. Give me a second. So what I did was, simply I did this. It's on my blog if you're interested in looking at it. So here is my tail call optimization in Java 8. All that I'm doing is, I'm calling iterate, and I'm turning this into an evaluation on an infinite collection. I say, go call this method first, and then give me a tail call after that, and this will keep going until the tail call is terminated. This becomes purely a lazy evaluation, and Java 8 has lazy evaluation like Scala and Clojure does, and so I simply turned it. So there you go, 1 line of call to do tail call optimization in Java 8. So it's really power, and all that I did was about 8 to 10 hours of work and a run on treadmill later. I was able to put together what Scala does and what Groovy does within Java 8 without any compiler tricks at all. So it's really powerful. If you're interested, you can take a look at it on my blog. It's just amazing how Java 8 has turned around and provides these features. So good question. That's all I have. Thank you very much.